Any short-term prediction about a tropical storm or hurricane includes a track forecast, where's it going, and an intensity forecast, how strong will it be when it gets there. Over the years, track forecasts have improved tremendously, but not intensity forecasts. Here's a look at the average air in a track forecast 3 days in advance for each decade going back to the 1970s. Then it was almost 450 miles, but by the first decade of this century, the air had dropped to less than 200 miles. Now here's the 2-day forecast air. It went from almost 300 miles in the 1970s to 120 miles last decade. And finally, 1-day forecast airs went from 140 to 70 miles over that same time period. So a 3-day track forecast today is almost as good as a 1-day forecast was in the 1970s. And this forecast skill was on display last week with Irene. Now here's the Hurricane Center's 3-day forecast issued the evening of Sunday, August 21st. And there's where Irene was forecast to be the evening of the 24th. Here's where it actually ended up. That's an air of about 125 miles. Now here's the forecast issued last Wednesday evening, and there's where Irene was predicted to be last Saturday evening. And here's where it ended up, an air of less than 50 miles. Not perfect, but these were skillful 3-day forecasts. But the story is very different for intensity. We only have data going back about 20 years, so I've plotted the wind speed airs averaged over 5-year periods. And you can see that since the early 1990s, intensity forecasts really haven't improved, whether it's a 1-, 2-, or 3-day forecast. And frankly, the average airs in the intensity forecasts for Irene were larger than the averages shown here. And we know why track forecasts are better, but intensity forecasts aren't. Over the last few decades, much more data has been collected around hurricanes, mainly from satellites. And because hurricanes are steered by the larger scale flow around them, track forecasts have improved. But intensity changes are driven primarily by small-scale processes in and around the eye, and we don't have enough high-resolution observations of those details, even though we do have the computer power for models to realistically simulate features just a few miles in size. Of course, we do get some fine-scale data from hurricane hunters, and Dr. Fuqing Zhang and his team here at Penn State has shown that if you feed their Doppler radar data to the computer models, intensity forecasts greatly improve. But it's too expensive to have manned flights out there all the time. And NASA's experimenting with unmanned drones flying high above hurricanes. But we really need data down low, where heat and moisture from the ocean are feeding the storms. Essentially, we need a fleet of unmanned aircraft, tough enough to handle a hurricane's fury, but cheap enough that losing a few wouldn't be disastrous. I know of at least one company with a prototype looking for seed money to give that idea a real-life test. So what's brewing in the tropics this week? Paul Knight will tell us next in the extended forecast.